So today we are to find out by using Biot-Savart's law the magnetic field around an infinitely long straight current carrying conductor, say AB, at a point P. We are going to find out magnetic field produced by an infinitely long current carrying conductor due to at a particular point around this conductor, say at a distance A, from the conductor, so from a point Q, and suppose we are considering an elementary length dl, and from the center of this elementary length O, from the center O of this elementary length dl, we draw a position vector r vector. Okay, the distance from P to Q is A, and distance O to Q is, suppose, L. This is L, and this position vector from the point O point is R to point P. We are going to find out magnetic field at P. So, which is perpendicular to the position vector R. Okay, and suppose this angle is theta, then this small angle will be 180 degree minus theta. Okay. Now, for this current element dl, the magnetic field produced at P, according to Biot-Savart's law, will be given by dB. The magnitude of this magnetic field is dB mu naught by 4 pi I dl sin theta r square. Okay, this is the magnitude of magnetic field according to Biot-Savart's law produced at point P due to current element I dl vector. Dl is also a vector. Okay. In this figure, if we find sine 180 degree minus theta, it is, according to trigonometry, it will be again sine theta, right? So sine 180 minus theta is nothing but sine theta, which is from this triangle perpendicular by hypotenuse. So perpendicular is A, hypotenuse is R. Okay. Therefore, R is equal A by sine theta, that is A cosec theta. Okay, so we can put the value of R here, and also we have to find out the value of dl from this. How you see? If we write cot of 180 degree minus theta, since tan theta is equal to perpendicular by base, okay, here base is L, and perpendicular is A. If tan theta is perpendicular by base, then cot theta will be base by perpendicular. So L by A. Okay. L by A, cot, and we have cot 180 minus theta is equal minus cot theta is equal L by A. Also, L is equal minus A cot theta. If you differentiate, you'll get dl is equal differentiation of cot theta is equal minus cosec square theta. So minus minus will be plus A cosec square theta. Again differentiating theta, you will get d theta. Okay. So the value of dl is obtained from this equation, A cosec square theta d theta. So we have dl as well as we have r. This is r. Okay. So putting the value of r and dl in this equation, what we will get? Mu naught 4 pi I dl is equal A cosec square theta and sin theta is already there, d theta. In place of r, if you put the value of A cosec theta, it will be A square cosec square theta. Okay. Now, from this equation, mu naught I 4 pi A will be cancelled, cosec square theta will be cancelled, only sin theta d theta. Okay. So this value is obtained after putting the value of r and dl. Okay. Okay. Mu naught I by 4 pi A sin theta. Therefore, net magnetic field উলিয়াবলৈ হলে we are to integrate B is equal dB 0 to B is equal, we have to integrate this side, mu naught I 4 pi A is a constant quantity, we have to integrate sin theta because this is infinitely long, so we are to integrate in between two limits, lower limit as well as upper limit. So lower limit ki hobo? So when A point goes upwards, যদি A point to উপরে যায়, আমি dl টুক যদি লৈ যাও ইনফিনিটি লৈ, তেতিয়ালে থিটা টু কি হ'ব? থিটা টু ইনক্রিজ হৈ হৈ এটা সময়ত 180 ডিগ্ৰী হ'ব. Theta will increase up to 180 degree. So upper limit is 180 degree, that is pi. Lower limit, similarly, if B point is taken up to infinity, that is if we take this dl towards this side, then theta will decrease and it will decrease finally up to 0. That is lower limit is 0. So if you bring this point O to the side of B, then this angle theta will decrease up to 0. 0 is the lower limit, pi is the upper limit. So you have to integrate this. Okay, then you will get the final value. Then the magnetic field B, this one, is equal mu naught I by 4 pi A. If you integrate sin theta, you will get minus cos theta, right? Then lower limit is 0, upper limit is pi. Now put the value of lower limit and upper limit. Mu naught I 4 pi A. So if you change the limits, then minus sign will be positive sign. Cos theta, changing the limits, pi to 0. Then what you will get? Mu naught I 4 pi A cos 0 degree minus cos pi. Okay, cos 0 degree and cos pi. So mu naught I 4 pi A, the value of cos 0 degree is equal to 1, the value of cos pi is equal to minus 1. Okay, so finally minus minus will be plus, so plus 1, 1 plus 1, 2. So it will be 2 mu naught I 4 pi A. So 2 and 4 will be cancelled, only 2 will be here. So mu naught I twice pi A. Finally we got the value as mu naught I twice pi A. This is the magnetic field, net magnetic field produced by an infinitely long straight conductor at a particular point around it at a distance A from the conductor. So this is the final expression. For solving problem, if you want to write as mu naught by 4 pi, and this will be twice I by A, then you can write the value of mu naught by 4 pi as 10 to the minus 7, then twice I by A 10 to the minus 7 Tesla. You can write like this also. Okay, this is the final discussion of this application. Thank you.